Definition of a function. Objectives. Introduction. Definition of a function. Graphical illustrations. Functions are everywhere. For instance, mapping images to the names of the people on the images. Mapping digital songs to authors, genres, song name. Mapping MRI scan data to medical diagnosis. Mapping Quora answers to subjects or categories. Mapping internet clicks to AdWord suggestions. How temperature varied over some time during the day. Temperature as a function over time. At the fuel filling station, the price of gas as a function of the number of gallons purchased. There are many more uses of functions in our real life. The concept of functions is very important because of its close relationship with various phenomena of reality. For instance, the volume of a sphere is dependent on its radius. This dependency of volume V on radius R can be shown by V equals to 4 by 3 multiplied by pi R cube or V equals to F of R. Here, volume B is said to be a function of radius r and f is a symbol used to show the dependency of one variable on the other. Before going to define a function, we define independent and dependent variables. Independent variable. The symbol which can take an arbitrary value from a given set is called an independent variable. Dependent variable. The symbol whose value depends on independent variables is called a dependent variable. From the above instance, we observe that R is an independent variable and V is dependent variable. Now, let us define a function. Definition of function. Let A and B be two non-empty sets. Then, a rule of which associates each element of A with a unique element of B is called a function or mapping from A to B, and we write F maps from A to B. In other words, for every A belongs to A, there is B belongs to B, such that the ordered pair AB belongs to F and no two ordered pairs in F have the same first coordinate elements, then F is a function. Here, we also observe that the element B is called the image of A under the function F, and the element A is called the pre-image or inverse image of B. Representation of functions as Venn diagram. For finite sets x and y, we can always use Venn diagrams to represent a function. From the Venn diagrams, each element of x is having a unique image in y. So, both are functions from x to y. Now let us go through the Venn diagrams which are not functions. From the first Venn diagram, we observe that the element x1 in x has two images in y. From the second Venn diagram, we observe that element x2 in x does not have image in y. So, both are not functions. Graphical illustrations. If a vertical line meets the graph at the only point, then the graph represents a function. A graph does not represent a function if there exists a vertical line which meets the graph in 2 or more points. Now, let us go through the following graphs and we verify whether it represents a function or not. From the graphs, we observe that a vertical line meets the graph at only one point. So, all the 3 graphs are functions. From the graphs, we observe that there exists a vertical line which meets the graph in 2 points in the first graph and 4 points in the second graph. So, both graphs are not functions. Observation: all functions are graphs, but all graphs can't be functions. Illustration: for which of the following y can be a function of x where xy belongs to R? 1. X minus a whole square plus y minus b whole square is equal to r square. 2. X power 6 is equal to y cube. 1. Observe that x minus a whole square plus y minus b whole square is equal to r square. Implies y is equal to b plus or minus root over r square minus x minus a whole square. Here, for each value of x belongs to r, we get 2 values of y belongs to r. Therefore, the given relation is not a function. 2. Observe that x power 6 is equal to y cube. Implies y is equal to x square. Here, for each value of x belongs to r, we get the unique value of y belongs to r. Therefore, the given relation is a function. Summary: